You are not supposed to notice this. Right now, everything around you is moving. Earth is spinning, the sun is moving, and our galaxy is drifting through space at unimaginable speed. But here is the strange part. All of it is moving in the same direction, towards something we cannot see, something hidden behind a blind spot in space, where our view simply breaks. We call it the zone of avoidance. And behind it, there is something massive enough to pull entire galaxies toward itself. We call it the Great Attractor. But the deeper question is not what it is. It's why everything is moving toward it. And to understand that, we need to zoom out, way beyond our galaxy, because what we are seeing might not be a single force at all, but part of something much larger. The universe is not empty. It is filled with structure, not random, not scattered, but organized on scales so large that they are almost impossible to imagine. Galaxies do not exist alone. They gather, they cluster, they form groups, clusters, and superclusters. Our own galaxy, the Milky Way, is part of a small group of galaxies called the Local Group. It includes Andromeda, the Triangulum Galaxy, and dozens of smaller satellite galaxies. At first glance, this might seem like a simple neighborhood in space, but this neighborhood is only a tiny part of something much bigger, a structure so large that it stretches across hundreds of millions of light years. We call it laniakea. Laniakea is not a solid object. It is not something you could point to in the sky. Instead, it is defined by motion, by flow. Galaxies inside laniakea are not sitting still. They are moving along invisible paths, guided by gravity, like rivers flowing downhill, except the landscape is invisible and made of gravity itself. Everything inside this structure is slowly drifting toward denser regions of space, regions where gravity is stronger, where matter has gathered over billions of years. And somewhere inside this enormous structure lies the region we call the Great Attractor. But the universe does not behave like a simple map with one center. There is no single point everything moves toward. Instead, there are multiple gravitational influences overlapping each other, competing, interacting, pulling in different directions. The Great Attractor is one of these regions, a place where galaxies appear to be flowing inward, as if space itself is bending toward something hidden. But what makes it so strange is not just its influence. It is the fact that we cannot see it directly. There is a reason for that. From our perspective on Earth, part of the sky is blocked, not by distance, but by our own galaxy. The Milky Way is full of dust, gas, and dense star fields, so dense that it creates a kind of cosmic fog. This fog blocks our view of anything beyond it. This region is called the zone of avoidance, and behind it lies the direction of the Great Attractor, a region that is literally hidden from direct observation. So for decades, we only knew something was there because of what it was doing to everything around it. Scientists first noticed something unusual in the 1970s when they studied the motion of galaxies near us. The Milky Way was not just following the expansion of the universe, it was moving in a specific direction, at high speed, and not alone. Nearby galaxies were moving with us, as if they were all being pulled by the same invisible source. This was not random motion. It was coordinated, a large-scale flow of galaxies across space. But the question was simple. What could possibly cause this? To answer that, scientists used a completely different kind of observation. Not visible light, but the oldest light in the universe, the cosmic microwave background. This is the faint afterglow of the Big Bang still filling all of space. It is almost perfectly uniform in every direction, but not completely. There is a small imbalance. One side of the sky appears slightly warmer, the other slightly cooler. This difference is caused by our motion through space. As we move toward one direction, radiation becomes slightly compressed. This effect allowed scientists to calculate something surprising. Our galaxy is moving at about 600 kilometers per second toward the constellation Centaurus, toward something massive and unseen. At first, scientists tried simple explanations. Maybe it was nearby galaxy clusters. Maybe it was an uneven distribution of galaxies in our region. But none of these explanations were strong enough. The motion was too large, too consistent, too widespread. So astronomers began mapping the universe in 3 dimensions, measuring the position and speed of thousands of galaxies. And what they found changed everything. The region of the Great Attractor was not empty. It contained dense clusters of galaxies, one of the most important being the Norma cluster, a massive collection of galaxies hidden behind the Milky Way's obscuring dust. When finally detected using X-ray and infrared observations, it revealed that the Great Attractor region was not empty space at all. It was filled with structure, mass, gravity, activity. But even then, something was missing. Because the observed mass still could not fully explain the speed of our galaxy. Something larger had to be involved, something further away. And when scientists zoomed out even more, the picture became even more extreme. Beyond the Great Attractor, at a much greater distance, lies one of the most massive structures in the nearby universe, the Shapley supercluster, a gigantic concentration of galaxies stretching across hundreds of millions of light years. It contains thousands of galaxies and enormous gravitational influence. And it does not just affect its local region. It appears to influence motion on even larger scales, including the motion of the Great Attractor itself. This changed everything, because it meant we were not being pulled by a single point. We were part of a chain of influence. The Great Attractor pulls our local region, but Shapley pulls the Great Attractor. And beyond that, there may be even larger structures still shaping everything we observe. A layered system of gravity, a network of competing pulls across the universe. More recently, another structure entered this picture, the Vela supercluster. Hidden partially behind the Milky Way, it was difficult to detect for years. But new observational techniques revealed something important. It is massive enough to contribute to large-scale motion in our region of space, not replacing the Great Attractor or Shapley, but adding to the complexity of the system, meaning our galaxy's motion is not caused by one object, but by many overlapping structures across enormous distances. And this leads to a deeper realization. The Great Attractor is not a single mysterious entity. It is not a hidden object waiting to be discovered like a planet in darkness. It is a region of convergence, a place where multiple gravitational flows overlap, where cosmic structure becomes dense enough to influence motion across millions of light years. It is part of the cosmic web, the largest known structure in the universe. The cosmic web is not a static design. It is dynamic. Galaxies move along filaments like currents in an ocean. They gather into clusters. They leave behind voids. They reshape the structure of space over billions of years. And we are inside it, moving along one of these cosmic streams, heading through a landscape we cannot step outside of to observe. But even this is not the final layer of the story, because the universe is not only structured by gravity, it is also expanding. Space itself is stretching outward, and this expansion is accelerating, driven by something we call dark energy. At large enough scales, this expansion becomes stronger than gravity, meaning that over time, galaxies will drift further apart, clusters will become isolated, and the cosmic web will slowly stretch beyond recognition. So, what does that mean for us? It means that the motion we observe today is temporary. The flows of galaxies toward the Great Attractor, Shapley, and Vela are part of a universe that is still connected, still interacting, still forming structure we can observe. But in the far future, this will change. As expansion continues, many of these structures will move beyond our observable reach, not because they disappear, but because space itself carries them away. And yet, right now, we exist in a rare moment. A moment where the universe is still visible in large-scale structure, where we can map galaxy flows, where we can trace invisible currents across hundreds of millions of light years, where we can still ask questions about what lies beyond what we can see. So the Great Attractor is not just a mystery. It is a clue, a reminder that everything we call still is actually in motion, that galaxies are not fixed points in space, but travelers in a vast and evolving structure, and that even our own galaxy is part of a journey we did not choose, because the universe is not a collection of isolated objects. It is a system, a flowing structure of matter, gravity, and time, and we are inside it, moving with it without ever truly standing still.